So now let's move ahead with our next topic, which is ingest data with Spark and Microsoft Fabric notebooks. Okay. So let's discuss what Fabric notebooks offer over the other ingestion option. So, unlike manual uploads, notebooks provide automation. It ensures a smooth and systematic approach. Though data flows offer a UI experience, however, they are not as performant with large data sets, and pipelines allows us to orchestrate the copy data and may require data flows or notebooks for transformations. Therefore, notebooks provide a comprehensive automated solutions for ingestion and transformation. So, Fabric notebooks can be easily created in many parts of the Fabric services. Okay, notebooks are stored in the workspace they are created from, which may not be the same workspace where the lakehouse exists. Okay, and notebooks are excellent for initial testing, as you can see the code output directly in line with the code and make quick changes. You can also run individual cells, freeze cells, or run cells in a notebook. So by default, Fabric Notebook use PySpark, which uses the Spark engine to allow a multi-threaded distributed transaction for speedy processes. You can use HTML Spark, Spark SQL, and Spark R as well. Okay. However, they may not have the full benefit of the distributed system. Okay, so this was a brief introduction about Fabric notebooks. Now let's move ahead. Okay, so Fabric Notebook offers intuitive shortcuts for certain platforms. However, if your data resides elsewhere, you need another method. So here's a basic example of connecting to Azure Blob storage with Spark. Okay, so here this PySpark code it's defines the parameters and constructs that the connection path, and then reads the data into the data frame and then shows the data in the data frame. Okay. Then, in previous example, we connect to the source and read the data into the data frame. Now, depending on your source, you may need a different authentication types, such as service principal, OAuth, etc. So here is an example connecting to an Azure SQL database with a service principal. You have now successfully connected to external data with Spark and read it into a data frame in a Fabric notebook. All right. Okay. Now that we have connected to data, we need to save it into the lakehouse. And lakehouses, it supports structured, semi-structured, and unstructured files load as the Parquet file or Delta table to take advantage of the Spark engine. So OneLake supports a wide variety of file formats, including many formats that are commonly used in Spark code, such as delimited text, JSON, Parquet, Avro, ORC, and others. So in most cases, Parquet is the preferred format because of its optimized columnar storage structure and efficient capabilities. Okay. Now, to our delta tables. So, delta tables are one of the key feature of Fiber Lakehouse. Easily ingest and load your external data into a delta table via notebooks. Fabric notebooks easily scale for large data. Therefore, read and write optimization is the key. And considering these optimization functions for even more performant data ingestions. Okay, now if we talk about V-order, so V-order enables faster and more efficient reads by various compute engines such as Power BI, SQL, and Spark. V-order applies special sorting, distribution, encoding, and compression on Parquet files at right time. And optimized right, if we talk about optimized right, so it improves the performance and reliability by reducing the number of files written and increasing their size. It's useful for scenarios where the data tables have suboptimal or non-standard file sizes, or where the extra write latency is tolerable. Okay. Now, points to consider by users for ingested data. So you have now ingested raw data in Fabric Lakehouse, also known as the bronze layer of a Mendelian architecture. And before moving to the transformation and modeling steps, consider where to transform and how users interact with the data. Okay, so data, it's good idea to do some basic cleaning like removing duplicates, handling errors, converting null values, and getting rid of empty entries to ensure data quality and consistency. Also, thinking about different people who use the data is crucial. Okay. And data scientists usually prefer fewer changes so they can explore white tables. They would likely want access to the raw ingested data. Fabric's data wrangler then lets them explore the data and generate transformation code for their specific needs. Whereas Power BI data analysts may require more transformation and modeling before they can use the data, while Power BI can transform data starting with well prepared data allows analysts to develop reports and insights more efficiently. Okay, so here also we have a demo to perform. So let's switch our screen. All right. Okay, so in this demo, we will for ingesting the data with Spark and Microsoft Fabric notebooks. Okay, so here we will use PySpark to connect to an Azure Blob storage path, and then we'll load the data into a lakehouse using write optimization. So first of all, we will create a workspace inside our Synapse Data Engineering. So we'll select it and we can create a workspace with the help of left hand menu bar. Okay, so I have already created the one. So let me just select this one, or if you want to create a new one, you just click on new workspace and then you can provide a name of your choice. So once you click on or you create a new workspace, it should be empty. Now we will create a lake house inside our workspace. So for that, we'll click on new, and then we will select lake house, and then we can provide it a name. So I can give it my lake house. So lake house has been created, and as of now there is no table or files. All right. Now we from these three dots of files, we will select these three dots, and then we will click on new subfolder. And now let's name it as raw data. Okay, so now we can see a subfolder raw data inside our files folder. Now we will select the properties from the files menu, and in the properties we will copy the ABFS path to our notepad, and we will use it later on. Right, so I have copied the path. Now we will create a Fabric notebook, and we'll load the external data into it. So from the top menu of the lakehouse, we will select Open Notebook and New Notebook. So a new cell, code cell. We can see a default cell here. All right, and code is set to the PySpark Python. Now inside this, we will paste some code. So let me just copy paste the code. All right, and we'll construct a connection path as well. All right. Now, if I can select this run cell from the left hand side. So it will connect and read the data frame, read the data into the data frame. Okay, so this is our expected output. Okay. Now we will write the data to a file, and for that we need that ABFS path for our raw data folder. All right, so we will insert a new code cell here. And again, I will just copy some code. All right, and here insert ABFS path. I will just paste the path that we have copied in our notepad. All right, now we will run the cell. Okay, so it is throwing some error. Let's see. File name yellow taxi. Okay, okay. Have I missed something? Okay, so there's alignment problem. That's it. Okay. Spark job in progress. So basically, what it is, this code is doing, it is writing 1,000 rows to a yellow taxi parquet file. Okay, so it has succeeded. Now let me just refresh my file folder. And here I can see a folder, yellow taxi. Okay, and if I just explore it, so I can see a parquet file named inside our folder yellow underscore taxi. All right. Now we will transform and load the data to a delta table. Okay, so again, we will I will just minimize it. And here I will add a code cell again, and I will just copy paste some code. All right, now I will run it. So basically what is happening here, this is adding a timestamp column, date data load underscore date time to log, and when the data was loaded to a delta table. It is also filtering the null values in store and forward flag, and it is loading the filter data into the delta table, and after that it is displaying the single row for validation. All right. So, okay, let me run it again. Okay, so now we can see single row. Okay, so now we have successfully connected to external data and written it to a Parquet file. Then we have also loaded the data into a data frame and transformed the data and loaded into the delta table. Okay, let me just refresh one more time. So now we can see a yellow taxi delta table here. All right. Now we will optimize the delta table rights. All right. So for that, again, I will add a code cell. And again, I will copy some code. Let me run it. So result is same as that of the above code, before the above code. Okay, now if we take a note of the run times for both the code block, so we can see the difference between the time is varying, and we can see a clear performance boost with the optimized code. All right. So here is the code used for optimization. So here we enable order, and we enable automatic data optimization right. Okay. Now we will analyze the data table with SQL queries. So for that, we'll just again create a code cell. Okay. Now I will run it. so I can see the result. So basically, we are loading a table into a data frame. Then we are creating the temporary SQL table, and then we are querying that table using the SQL command. Okay, and then we are displaying the top 10 rows of it. Now we will add another code. Okay, let me just run it. Now we can clearly see the execution time difference between these two tables. Here the time of execution is 2 seconds and some milliseconds. And in the second quote, here if we can see that the time is decreased, runtime is decreased. Okay, so this is the difference between non-optimized data, table with non-optimized data and table with optimized data. Okay, so this was it with this lab. Okay, thank